So today's video is going to be an interesting one because as you have read the thumbnail, we will be discussing whether G changes. Is it possible that G will change? Actually, this question was asked to me by one of my friend and I found it very interesting, and so I thought I should make a video on it. So first, before we discuss the question, we need a good background about special relativity. Now, let us come out of the Newtonian umbrella and travel to Einstein's paradise. Now, Einstein's favorite special relativity deals with particles traveling at very high speeds, speeds close to the speed of light. And here things change. Things are not the way they are in the Newtonian world. Okay, so one pointer that you need to notice: when an object moves, okay, as its velocity increases and approaches to the speed of light, the mass as well increases along with the velocity. So this is the point that I will be using in discussing the question. So let's head on to the question. So here we have a free space. There are no heavenly bodies around. And in this free space, we have our two particles. And let the distance between them be r. Okay, so they are separated by r distance. Now, let us discuss two properties of the particle, that is mass and charge. So both these particles have mass, but they have no charge, and so there will be no electrostatic force acting between them. So the only force that is acting between them is the gravitational force. Now what we do is we accelerate this particle very fast and we take it to the speed of light. So at some time t, the speed of the particle is equal to the speed, is not equal but approximately close to the speed of light. Then we accelerate these particles a bit more so that its speed is speed of light plus a little bit more of the speed. Okay, so let's denote the 2 times by t and t plus delta t. So the velocity at time t is nu. Okay, here we denote the speed of light by nu, which is approximately speed of light, and at time t plus delta t we denote it by nu plus dv. Now, as I've discussed in a couple of seconds ago, that as the velocity increases and velocity tends to the speed of light, their mass also increase. So at time t, if the mass was m, at time t plus delta t, its mass is going to be m plus dm. Okay, so now the main part. Let us denote the force between the gravitational force between these two particles by Fg. So this is the gravitational force between these two particles. And now you need to pay a close attention, because at time t and time t plus delta t, the force is going to be same. Now you will say the mass is increasing, so the gravitational force also should increase. I would agree if we were in the Newtonian world, but now we are out of that. We are discussing things where particles are traveling at a very high speed, and since these particles have mass, and I know particles having mass and traveling with speed close to the speed of light sounds totally absurd, but it is a kind of assumption that we are taking here. Okay, so they will have momentum because they have mass, and so they will try to resist the change, okay, between the distance change in r. So they will travel having the same distance r. So the gravitational force between them needs to be constant if r is not changing. Okay, so I hope this was clear. Now we will discuss the gravitational force at time t and time t plus delta t. So at time t, it will be F is equal to g m square, that is m into m since the particles are identical, divided by r square. Okay, and at time t plus delta t, it's going to be g dash, I'm not saying g here, I'm saying g dash into m plus delta m the whole square divided by r square. And this is happening at time t plus dt. Now if you notice here, the particles have mass m at time t and m plus dm at time t plus dt. That means their mass has increased, but the force is constant. Now in order to keep the force constant, this g should be less than this g, because m is less here and more here. So g should be less here and more here in order to keep the force constant. In this way we can conclude that G changes for a particular interval of time, because see, the force might change after a certain period of time. It will take time. There will be some delay between the change in the force and the change in the mass. Okay. So the final conclusion is G might change. But this is not what I'm concluding. This is what I want to ask you all. Will it actually change, or will the formula for the gravitational force change for particles traveling at very high speed? Because when particles travel at high speed, everything changes, right? Okay, so this is my question. Please comment your views whether G will change or will it remain constant, because the formulas can also change, right? So here I will end the video. Thank you.